Stripping down science. The Naked Scientists.
Hello, welcome to The Naked Scientists. It's Chris Smith and Phil Rosenberg with you this week. Hi, Phil.
Hi, Chris.
Now, coming up in this week's programme, we'll be finding out how engineers have launched an inflatable space station. Apparently it comes complete with a bingo machine, apparently. Also, a new way to combat Alzheimer's disease, that's coming up. And how to heal a broken heart using your own stem cells.
Also this week, we'll be hearing about how chemical tricks to make yourself look younger and some stop-smoking strategies. That comes from our reporter from Chemistry World, Richard Van Norden. Also on the way, Question of the Week will be solving this potentially explosive problem.
Hi, I'm Sebastian from London. I'd like to know what would happen if I was to fall out of a spacecraft without a spacesuit on. Would I explode as space is a vacuum?
Sounds nasty. We'll also be finding out how red deer in Scotland, as seen in Autumn Watch last year, are helping researchers to rewrite the scientific textbooks. And in Kitchen Science this week, we'll be showing you a really funky experiment to do with liquids in a cup. You'll need a polystyrene cup, some carpet and some water.
And if you're the first through on the telephone with the correct results, then you could win yourself a signed copy of our book, That's Naked Science. It's in all good bookshops, $7.99. Another way to get a copy, though, is to have a go at this week's teaser. Can you tell us, on an average day, how many cigarettes, and this is in the light of the fact that smoking is now banned in public places in the UK, how many cigarettes are smoked all around the world, worldwide, on the average day?
And don't forget, this week it's our Science Q&A extravaganza. We're answering all your questions.
The Naked Scientists podcast, powered by UK Fast, the UK's best hosting provider. On the web at ukfast.net.
Have you ever wondered what would happen if you launched a bouncy castle into space?
It would probably go bang, wouldn't it?
Well, it would if it was just normal bouncy castle, but Las Vegas-based space company Bigelow Aerospace have actually just this week successfully launched their second inflatable spacecraft into Earth orbit. It's actually made of some rather high-tech, tough material, so it doesn't go pop.
But presumably you don't launch it blown up, though, do you?
No, it's launched compressed and all basically rolled up around a central core. It's launched into space and then inflated when it gets there.
How big is this thing?
It's a fairly large thing. It's a couple of metres across, essentially, and it's sort of a cylindrical shape. This is the first sort of inflatable space station, commercial inflatable space station that they're aiming to build up in space. And they're aiming to get the whole thing up there by about 2010 and get some people on there. And the actual final thing is going to be called Sundancer, this thing they're aiming for.
It's like a hotel, then?
Yeah, essentially. I mean, the first one for 2010 is going to be able to hold about 3 people.
And it'll be quite a party up there, then.
Two's a crowd, three's a party, I guess.
Is that the staff, or there won't be any staff?
Well, that's about all you can get, I'm afraid. So it's going to be basically a commercial sort of thing, maybe to do microgravity research on it initially. But in 2012, they're going to be launching an extra add-on module. And once it gets to that stage, it's actually going to be bigger than the current International Space Station that we've got in orbit at the moment around the Earth.
But what's the actual basis for this? And then how does it actually work? Is it just sort of bobbing around in space? Is it in orbit? What's the basis to it?
Yeah, basically it's in orbit around the Earth at the moment. It basically is launched up into space and goes into orbit around the Earth. And it's inflated when it gets up there. And this is basically a test run. So at the moment, all they've got on there is some instruments, essentially, and a lot of cameras. They've got 22 cameras on there, on the outside and on the inside, to sort of look and see how the thing's working and take photos and stuff like that of the Earth and actually of the craft itself. And actually, one of the things they were doing this time was they had a get your stuff in space sort of thing, where you could pay to have them take stuff up there with them as they went. So a lot of people sort of paid to have photos and memorabilia and things taken up there. And actually the first photos have just come back and you can see all these little photos of various people sort of floating around on the inside of this space station.
What's this about a bingo machine?
Well, the idea is that they've got a bingo machine up there. They haven't tested it out yet. This was only launched just this week, and we've only got the first sort of pictures back from it on Friday. But within the next few weeks, they've got this bingo machine that's going to start playing bingo in space. So if you're
obviously going for a sort of older audience, an older visitor then, aren't
Absolutely. Maybe if you've got your blue rinse on, you'll be really keen to get on this space station. But essentially, if you log onto their webpage, in the next few weeks, you'll be able to play space bingo, and who knows, maybe win yourself a few prizes.
I hope so. Watch this space, I guess, is the way to come out the back of that. But an interesting story back here on Earth is that scientists have come up with a novel way to tackle the problem of Alzheimer's disease. And this is something that really affects older people, but it's getting more common because more people are living longer. In fact, more people than ever before are more than 80 years old now in the UK. And it's not just the UK. Everywhere in the world, people are living longer because our quality of life is getting better. And about 25% of people over the age of 80 are beginning to show signs of Alzheimer's. And the drugs that have become available over the last few years to try and tackle it, actually all they do is sort of put a sticking plaster over the problem. They tackle the symptoms, they don't tackle the root cause of the disease. Now, what we know about Alzheimer's disease is that it's caused by the build-up in the brain of an abnormal or pathological protein called beta amyloid. And this is produced normally by nerve cells, just because it's an essential part of the brain. We don't know what the protein does, but it does something important because you see even yeast cells and other animals having it. So it obviously does an important job in the cell. And when it comes out of the cell, normally enzymes cut it to small pieces and then it goes away. But sometimes you switch on an alternative way of processing it, and this is called beta secretase. And this turns it into a form which forms these pathological aggregates in the brain, which then kill brain cells. And so what researchers at Purdue University, a guy called Aaron Ghosh, have done is to design a drug which can lock onto this beta secretase mechanism and block it, switches it off. So you should actually be able to stop the formation of this beta amyloid protein. The idea being that if you stop it forming, you might be able to therefore prevent or slow down the progress of Alzheimer's.
OK, so this is a preventative thing rather than a cure then, is that the idea?
Yeah, the idea is to stop it happening in the first place or possibly reverse the symptoms a bit, because all the other treatments people have tried to unleash on Alzheimer's have literally tackled the symptoms. They try to boost the levels of a nerve transmitter in the brain called acetylcholine, and that's associated with, when you have a reduction in that, the symptoms of Alzheimer's. So boosting its levels should make the problem a bit better, but at the end of the day the disease is still carrying on. This approach, which is now in clinical trials over in America, just to test its safety, should actually tackle the root cause of Alzheimer's disease. And if it goes well and this drug turns out to be safe, it's a drug which is called CTS21166 because it's in clinical trials at the moment, then they'll have a clinical trial with actual Alzheimer's patients next year.
OK, excellent. Hopefully we should be looking forward to a long and healthy retirement then in the future. OK, I'm going to go back up to space now, quickly. If you've ever wanted to take part in astronomy research but don't have a telescope, I've got just the project for you now. This is called Galaxy Zoo. Now, essentially, a galaxy is just a cluster of stars, billions of stars, though, a big cluster of stars, essentially, that are just swirling through the universe, essentially. Now, our sun, for example, is in a galaxy called the Milky Way, and it's basically the Milky Way is sort of a big flat pancake shape with sort of spiral arms on it, this spiral shape with lots of young hot stars in, and because of that we call it a spiral galaxy, essentially.
There's a few of those on telly this afternoon at the Princess Diana Memorial concert. But anyway, sorry.
Absolutely. So that we call that a spiral galaxy anyway. But there are other types of galaxies out there as well, sort of. Some of them are called elliptical galaxies, are sort of big amorphous blobs of galaxies that have really much shape and not this spiral pattern on them. And essentially, a robotic telescope called the Digital Sloan Sky Survey has actually been automatically going around and taking pictures of these galaxies. And it's now accumulated at 1 million galaxies that it has these pictures of. But scientists actually haven't got the time to go through them all and categorise them and actually work out what they are, whether they're these spiral types or these elliptical types.
Why is that useful?
Well, it's useful.
Just a simple question.
It's useful because once we know what types of galaxies are out there, we can actually try and work out how they've formed. Some people think that spiral galaxies, if they collide with other spiral galaxies, will actually become this big amorphous blob and form an elliptical galaxy. And by taking all these different pictures and looking at different ones, we can try and work out if that's the case or not. If that's
so basically how galaxies are evolving over time?
Absolutely. Work out how they're forming and how they're evolving. Now, essentially, computers are really bad at doing this, actually, they've found. They are not made for telling the difference between a spiral galaxy and an elliptical galaxy.
So you need a human eye.
But people are really good at doing that. People are good at spotting patterns. And actually, as it's turned out, scientists are actually quite bad at doing it as well. They found that general members of the public are actually better at doing this than scientists. So they've launched this webpage called www.galaxyzoo.org, and you can go and sign up, and you actually get to be the first people to look through these pictures of galaxies. You actually get to be the first human eyes to ever look at these galaxies, because no one's ever had time to do it before.
Do they get people to sort of double-check it to make sure that some people aren't getting it wrong and skewing the data?
Well, essentially, the way we're hoping it will work is that possibly not, because there literally probably won't be enough resources for people to go through and check. But hopefully, if some people get it wrong one way and other people get it wrong the other way, then it will all kind of cancel out, and hopefully it will all work out fine. So if you want to really be keen on astronomy and get involved, then just log on to www.galaxyzoo.org and you can sign up there.
Do you get to name one after yourself?
No, unfortunately not. There's a whole committee to go through to name galaxies, and you've got to discover them yourself first. That's how it works, I think.
Damn. Oh, well, I'll have to stick with this then, which is that there's a very interesting study which has come out of Purdue University. A group of researchers in the UK. It's a group of US researchers, but they've also done some work in the UK. And one of the leaders is Douglas Lasordo. It's very interesting. They've been looking at repairing people's hearts using their own stem cells. And the idea behind this is that if you use your own stem cells, the immune system won't reject the cells when you put them into the body. And they're looking at people who've got very bad heart disease or angina, so pain in the chest when you try and do anything. And they took a small group of 24 patients who are 48 to 84 years old who had very severe heart disease. And they gave them a hormone injection with something called GCSF, which causes stem cells to come out of the bone marrow and into the bloodstream. And they were then able to go to the vein and take a small sample of blood and collect these stem cells, and then they isolated just the stem cells, and then using a very clever technique, a catheter threaded into the heart through a blood vessel, they injected these stem cells into the wall of the heart, into diseased bits of the muscle, and then they followed the patients up for 3 to 6 months afterwards. And the patients were divided into two groups. They either had real stem cells or they just got a placebo, some salt water injected. And what they found was that when they had the patients who got the real stem cells, their cardiac function, what they could do, what they were able to achieve, went up enormously. They went from being barely able to get out of a chair to being able to manage flights of stairs. So they're very encouraged, and they think what these stem cells are doing is releasing small amounts of growth factors into the wall of the heart, and this is encouraging new blood vessels to form, and this boosts the supply of oxygen and blood getting to the muscle, and this means that muscle cells that weren't working very well because they weren't getting very much blood start to work better, and this boosts the ability of the patient to do work.
So it's almost like giving the heart a little bit of extra fuel by getting that extra blood there and extra oxygen there.
It certainly looks like it. Well, let's hope that it works. Anyway, there's just a small trial, but it's certainly a step in the right direction, potentially. Well, it is The Naked Scientists with Chris and Phil, and we have a teaser running this week. What we want to know is, because we now have a nationwide smoking ban right across the UK in public places, how many cigarettes actually get smoked on the average day around the world? How many cigarettes get smoked every day all around the world?
And the first answer we've got in so far is Margaret Wilson-Hines from Peterborough, and she says too many. I agree with that one.
You can't argue with that.
Absolutely true.
The Naked Scientists, supported by the Wellcome Trust.
An email here from Steve Hughes, and he says, "Hi all, just wanted to bang off a quick note to let you all know how much pleasure I get from listening to your podcast. I'm a home-based computer programmer. I listen while I'm taking the dog for a walk every lunchtime. I probably make a fairly peculiar sight as I stroll across the meadows, grinning from ear to ear as I learn about colliding galaxies or short-sightedness in Singapore, but not at the same time, presumably. And it's also important to me to see how vastly entertaining I find your programme and how bereft I would feel without it. So, well, thanks very much for that, Steve."
We've got our first question in today for our Q&A show. This is from PK Sinner, actually in India. He says, "Hi Chris, my question is, what prevents venomous animals being knocked off by their own venom? For example, as the venom is being made in the glands. If I inject a cobra venom into a cobra, would it die?"
Fabulous question. The reason that snakes don't poison themselves, the reason that scorpions don't poison themselves from the venom they make in their stings or in their fangs, is because it's kept in a very special compartment in the body that's specifically designed not to let the venom out and not to be sensitive to the effect of the venom. Now, what happens in a snake's poison glands is that there are specialised cells that have got genes turned on in those cells that tell them how to make the cocktail of proteins, because snake venom is a protein, which they then squirt out into a special system of ducts that are lined by these cells that are designed not to be sensitive to the venom. So the venom gets produced in these cells, it trickles down these ducts and into a special bag which holds it and keeps it safe and out of the rest of the snake's body until it's needed. And then when the snake wants to bite somebody, of course its teeth are hollow, and if you look at a cobra, it's got curved teeth. And the idea of this is that these very sharp teeth, which are curved, mean the snake can lock onto something, hook its teeth in, and then muscles around the bag containing the venom contract, and it squirts the venom out of that bag down the hollow teeth and inside the tissue of the victim. And that means that when it gets into normal tissue, there are no defences in the normal tissue against the venom like there are in the specialist tissue in the glands that make the venom. I suppose you can think of this as being identical to your stomach, because we make digestive juices in the stomach, including acid and enzymes that can break down our body. But they don't break us down, they just break down our food, because the stomach has a special lining that protects it from the effects of the digestive enzymes and the acid. So, in other words, it's pretty much the same thing going on in the snake's glands, so that it doesn't actually get the poison coming out of the gland and into the rest of the snake. Great question.
So if you did inject a cobra with cobra venom, it would actually really suffer. So if it sort of bit its own tongue or something, then it really would be in trouble. Oh
sure
dear.
Too. I've got a caller here. Andy is on the phone. Hello, Andy.
Hello, mate.
What can we do for you?
The sun. What is the surface made of, and does it actually have a surface?
Okay, well, the sun itself is actually basically made of gas. It's not got a solid surface at all. It's just literally made of mostly hydrogen and a bit of helium and some really trace amounts of other stuff as well. So essentially there's no solid surface there. However, if you look at a photo of the sun, you will see it's got a very definite edge to it. And the reason why it's got that edge is not because the gas just stops at that particular point. Actually, it kind of carries on diffusely out to, thousands and thousands of kilometres. But essentially, there's a point where the sun is hotter in the centre and cooler on the outside. And there's a point where that hot gas becomes cool enough that it becomes transparent. And that's what you see as the surface of the sun.
How hot's the outside bit?
The outside's a few thousand degrees, maybe 5,000 degrees Celsius. So
and the inside?
Pretty hot. Inside is millions. It really is absolutely a colossal temperature. And that's why it produces so much energy, because at these high temperatures, you can get nuclear fusion happening, which is the same sort of thing that you get in a hydrogen bomb, essentially. And that's going on all the time in the centre of the sun, and that's what gives it its energy and gives it the heat.
You also get that, it's quite interesting because you've got material streaming off the surface of the sun as the solar wind, haven't you?
Yeah, absolutely. The sun's actually quite an active star. It's throwing material off all the time in these solar winds, just blowing material away. You also get sort of prominences and really big storms that blast large quantities of material and charged material as well. And sometimes they can hit the Earth and actually can be quite devastating. It can take out power lines, take out satellites in orbit. It can be quite a problem in this modern age when we rely so heavily on satellites and electricity.
Quick go at the quiz, Andy.
Yeah, go on, mate.
The waste produced by one chicken in its lifetime can supply enough electricity to run a 100-watt light bulb for 30 hours. Fact or fiction?
Fiction.
Absolutely true. Chickens produce a lot of waste, but not quite that much. They could only run a light bulb for about 5 hours from a lifetime's waste.
Good one, Andy. You're on a roll. A pearl is an entombed parasitic worm. What do you think of that? Fact or fiction?
Fiction.
Unfortunately not. Actually, it's pearls form when the larvae from a parasitic flatworm carried by seabirds actually burrows into the oyster, and the oyster responds by turning it into a pearl, covering it in the stuff.
Cheers, Andy. 1 out of 2.
Cheers, mate.
Not too bad.
Bye-bye.
Kai is on the phone. Hi, Kai.
Hello, how are you doing?
I'm very well, thank you. Thank you for joining us on The Naked Scientist. What do you want to talk about?
Well, my question's about tea.
Okay.
And I hope it doesn't sound too trivial compared to global warming and other the world's problems, but if you make a cup of tea and then leave it for a few minutes and drink it all, and if you look back in the mug, you'll see a tea ring, a tea stain, only around the surface of where the tea's been. And my question is, why doesn't it stain the whole of the mug, and instead it just stains the ring on the top?
OK, Kai, let me ask you a question. When you look in your kettle, which you've used to boil the water, have you got lots of calcium on the element? Does it fur up?
Not really, I don't think so, no. I don't really tend to look inside the kettle.
OK. Have you got hard water in your area?
It's in Manchester, so...
Okay, it is a bit hard there. And the thing about hard water is it's got a lot of calcium, and this is in the form of what's called temporary hardness, calcium hydrogen carbonate, Ca, and then HCO3 times 2. And this is temporary hardness because when you put heat into the water, this breaks down and it produces carbonate, calcium carbonate, chalk, and also some more water.
Okay.
And why I'm telling you all this is because those calcium salts can bind to tannin in the tea and produce an insoluble precipitate, and that's called scum. And if you put soap into water, you get scum on the surface, don't you? You notice that you end up with this layer on top of the water. Well, what you're doing is producing natural sort of soap scum in your cup of tea, because the tannins and other things that have also got the dark pigment, the tannin in them, float to the top of the tea, and the calcium binds onto them and makes this insoluble sort of precipitate, these particles which float to the top of the tea, and therefore where the tea is interfacing or hitting the side of the cup, they stick, and that's why you get those rings, a bit like you get rings on a beer glass as you drink a bit. I saw a great advert actually for beer glasses, and it was I can't remember which type of beer it was, Phil, but it said it had he says something, and then there's this 1 inch high sort of drink down the side of the glass, this sort of tide mark, and then it says she says something. It's most of the pint.
Oh God.
Kai, do you want to go at the quiz?
Yes, please, yeah.
Sound travels 14 times faster in water than it does in air. Fact or fiction?
Say fact.
Unfortunately not. Sound does travel faster in water, but only 4 times faster.
Okay, got to get this one right, okay? There are 1,000 chemicals in a cup of coffee. More than 1,000 chemicals in a cup of coffee. Fact or fiction?
I'd say there's more.
Yeah, absolutely. He says more. Yeah, absolutely. And out of all of those, only 26 have actually been looked at and analysed. And actually half of those tend to cause cancer, so maybe we should be wary about our cups of coffee.
Nice. Thanks for your call, Kai.
Okay, thank you.
So Naked Scientists with Chris and Phil, and it's our Science Q&A show. Now, for Kitchen Science this week, Ben and Dave are attempting to make a fountain using a polystyrene cup, and they've recruited the help of students from Parkside Community College in Cambridge. What are you up to, Ben?
Hello there, welcome to Kitchen Science. I've come to Parkside Community College, where of course I've met Dave Ansell.
Hi there.
And I've met Eleanor.
Hi.
And today, Dave said that we are going to make a fountain in a polystyrene cup.
It's not very complicated at all. All you need is a polystyrene cup, some water to fill it with, and a carpet. We've found that office carpets definitely work, the very short pile, hard-wearing carpets. And that's all you need.
Do you do experiments like this in school very often, Eleanor?
Well, we do some, but I haven't done one like this before.
How do you think Dave is going to make a fountain out of a cup and a carpet?
Don't really have a clue.
OK then, Dave, what are we going to do?
Well, what we want you to do at home, and Ellen to do in a minute, is push this cup across the carpet, going fairly slowly. And we found that it seems to work better if you push it with your fingernails about 1 centimetre up from the bottom of the cup. You'll find it vibrates a lot, and you're trying to get the bigger vibration as possible. Try not to knock the cup over, otherwise we'll just make your carpet wet, and that'll just make a mess. And that's it, really. See what happens.
Well, it's just as well we brought our own carpet. So if you are trying this at home, you need a polystyrene cup, fill it with water, and then put it down on a carpet and push it from towards the bottom of the cup, push it along the carpet and see what happens. Call into the studio, email in, let us know, and we'll get back to you later in the show.
Thank you very much, Ben and Dave. So, have a go. You could win yourself a copy of Naked Science, $7.99 all good bookshops. That's our book, and I'll sign it for you if you would like to have a copy. If you can tell us what happens when you push that cup along the floor. Now, very interesting, because if you watched Autumn Watch from the BBC last year, you'll have seen some red deer. They're in Scotland, and a scientist from the University of Edinburgh, which is Liska Crook, has been studying them, and they're helping her to rewrite, I suppose, some of the scientific textbooks. Liska, what have you found by looking at these deer?
Well, what we've found is that the genes that make a successful male do not always make a successful female.
What does that actually mean?
So, successful fathers, those who sire many offspring, will have daughters who actually have relatively lower breeding success.
Because Darwin would have had us think that as you breed populations, then you get survival of the fittest, and so everyone should get better as time goes on.
Exactly, but what our results are suggesting is that maybe the idea that some genes are better than others, that we can have a single measure of fitness, may just be too simplistic, and that it may depend on the sex of the individual animal carrying the genes.
So when you look at a male deer, for instance, what makes a good male is going to have big muscles, big antlers for fighting, that kind of thing. Those genes wouldn't help a female very much. Is that what you're saying?
Exactly. There are very different traits that contribute to breeding success in males, as you say, fighting ability and antler size, and also their skills at roaring. As anyone who watched Autumn Watch will have seen, they spend a lot of time during the mating season.
Does this apply to football hooligans as well?
They well do. But those are very different traits from the traits that determine breeding success in females. With females, those who produce the most number of calves across their lifetime will have the highest fitness, highest breeding success.
How did you actually do the study and find these results?
Well, we have data from more than 30 years of very intensive study of this population of red deer. And as anyone who saw Autumn Watch will have seen, we can recognise all the individual deer in the population.
Have they got names?
It is an entirely wild population.
Have you named them?
We do have names for every animal in the population, yes.
And your favourite?
Oh, well, there was Caesar on Autumn Watch, as people will have seen.
That's a kind of dog food, isn't it?
Yeah, and many other attributes as well. There have been some very successful females along the way as well. Aphrodite was one with a very nice name too.
She was very popular with the males, presumably.
She did very well, yeah.
So why is it that the males have unfit daughters? Why does the same work in the reverse direction? Do you end up with females that are very, very successful and they have lots of offspring? Are their offspring in the same way as the males' daughters are compromised? Are the female sons compromised then?
It's slightly more complicated when you look at it that way round, because with females, they contribute not only their genes to their offspring's later performance, but they also provide maternal care. So in the red deer, all that the males contribute to their offspring are the genes. With females, they provide both genes and maternal care. So a good quality female, although she may be passing on genes that are detrimental in a son, in a male offspring, she will also provide very high quality maternal care to both her daughters and her sons. And those two effects seem to balance each other out when you look at the performance of the offspring of the females. So we don't quite pick up the same relationship in relation to mothers' offspring performance.
So what would you say the bottom line is with this study, that because of these effects you've found that actually this mechanism contributes actually to a huge amount of genetic variation and diversity in a population?
Yeah, I mean, it's intuitively a very appealing explanation for a lot of the biological diversity that we see in nature. And this is important because the genetic differences that we see between individuals within a single species have always actually been quite a puzzling fact for evolutionary biologists. Because, as you mentioned, the process of natural selection is expected to favour only the best adapted individuals, Darwin's survival of the fittest. But what we're suggesting is that maybe this idea of a single fittest genotype is a bit too simplistic.
Liska, thank you very much.
Okay, thank you.
That's Liska Crook from the University of Edinburgh with the BBC's Autumn Watch Deer crop, if you like, which have helped her to effectively rewrite the scientific textbooks in terms of her understanding of how genetics and evolution work.
And now don't forget our teaser question for today. If you want to win a copy of Chris's book, The Naked Scientist, then all you've got to do is give us a call and tell us how many cigarettes are smoked every day worldwide.
Coming up in a second, we'll be hearing from Richard Van Noorden from Chemistry World about how you can quit the cigarette packet. He's got some interesting anti-smoking strategies up his sleeve. And also how chemistry can help you to look years younger. What's all that about? Also, we'll be finding out about bananas and ripe fruit in just a second.
Time now to cross the Atlantic and join our friends Bob and Chelsea for this week's Science Update.
This week for The Naked Scientists, we're featuring babies. I'm going to talk about their extraordinary ability to recognize languages, even before they can talk. But first, the sound of a baby crying is said to be one of the most disturbing in the whole world. But Chelsea has found a scientist who can turn it into beautiful music.
Don't you sometimes wish crying babies sounded more like, say, pianos? Well, you have your wish, at least temporarily, thanks to acoustician Kelly Fitz of the Starkey Hearing Research Center. He says morphing sounds together makes for cool sound effects and innovative music.
I always wanted to be a composer, and I thought that this way of working with sound, directly with recorded sounds, was of interest, but the tools just haven't really been strong enough.
His new technique first breaks down two sounds into their component tones, like this trumpet. Then he adds the components of one sound to the other to make a seamless transformation. Oh, so we're back to the baby again? I guess in the real world, there's no substitute for just changing the diapers.
Thanks, Chelsea. Babies can barely do anything for themselves, but those as young as 4 months can tell their native language from a foreign tongue, even if they can't hear a word of either. This according to a study led by psychologists Whitney Wykeham and Janet Worker of the University of British Columbia in Canada. Worker says past research has shown that babies can discriminate the sound patterns of different languages from a very early age.
But because speech is so richly multimodal, and because there had been some research showing that babies pay attention to both the visual and the auditory aspects of speech, we asked, can they use just the visual information alone? And can they use that to help identify speakers of their native language?
Her team showed babies silent videos of bilingual adults speaking alternatively in English and French. Wykeham says that babies' attention instinctively perks up when they detect a language switch.
So we found that at 4 and 6 months, babies from a home where only English is spoken can tell the difference between the languages. But their ability to tell the difference between the languages declined by 8 months of age.
On the other hand, babies raised in bilingual homes showed no such decline, suggesting that this ability persists only if it's needed. just as the ability to discriminate between certain vowel and consonant sounds fades away if those differences aren't important in one's native language. As for the ability to distinguish between languages by sight, it's not yet clear whether this is merely a phase of normal language development or the result of an evolutionary advantage for babies who could recognize other members of their community.
Thanks, Bob. Next time we'll talk about how scientists are trying to kick the healing process up a notch. Until then, I'm Chelsea Wald.
And I'm Bob Hirschon for AAAS, the Science Society. Back to you, Naked Scientists.
Thanks, Bob and Chelsea. And you can find more about that on the web at scienceupdate.com.
It's The Naked Scientist with Dr. Chris, Dr. Phil. It's our science phone-in. Email chris@thenakedscientist.com. Quick question from Keith in Watford by text, Phil. He says, Phil, an inflatable space station. What happens when one of the thousands of pea-sized meteorites punctures it?
Well, actually, it's supposed to be incredibly tough. It's made of multi-layers, and the idea being that if something hits the first layer, it makes a punch through that, but it breaks up the meteorite, and then it leaves like a powder that then hits this next layer. And you've got basically 12 layers, I think, on this particular space station. And actually, they claim it's actually harder and tougher than the International Space Station that's up at the moment. They think it's that tough.
Maybe we should make bulletproof vests from it then.
Possibly. It might even be the other way around. It might be that they've utilised bulletproof vest technology to make the space station.
Hallie's on the phone. Hi, Hallie.
Hi there.
What would you like to know?
Well, I was wondering about bananas, because I had always heard that if you put it in a brown sack with any other kind of fruit, that it would ripen the other fruit that was in the bag. But I thought that really wouldn't taste as good, like as a peach that you just let ripen on the tree in the sun.
And you're thinking, what should I go for? Brown bag or au naturel?
Right.
Well, the reason it ripens is because bananas happen to produce a huge amount of the ripening chemical that fruit uses, and that's called ethylene. It's the same stuff that when you feed it into a chemical process, you can turn it into polyethylene, plastic. And bananas secrete loads of this stuff. They put it onto any fruit that's near them in the fruit bowl, and because fruit all use this chemical to get ripe, if you put a banana near the other fruit, then it makes the other fruit ripen as well, in sympathy. So actually it's a natural way to ripen fruit. It shouldn't actually affect the flavour at all.
Oh, okay. Do any other fruits do that?
Yeah, pretty much everything uses ethylene. In fact, when you traumatise a plant, or if you actually pull leaves off and things, they also scream a bit of ethylene because it's used as a sort of growth signal. Plants use it to inform each other as to whether they're being eaten or not.
Oh, okay.
Ripe fruit make more of it than unripe fruit. So there was a few years ago a guy come up with a sort of handheld detector, the idea being that you could wave this at fruit in the supermarket and work out how much ethylene was coming off and therefore whether the fruit was overripe or not.
Oh, that's
I don't think it took
cool.
off, though. Do you want to go at the quiz?
Oh, sure, I'll try.
Deer mice, you've heard of them, lack a collarbone. Fact or fiction?
I don't know much about mouse anatomy, but let's just say fiction? Oh, no.
Unfortunately, they actually haven't got a collarbone, so it makes them really good at getting in and out of tight spaces.
Oh, okay, that makes sense.
You've got to get the next one right, okay?
All
the
right.
hottest planet in the solar system is Mercury because it's so close to the sun. Fact or fiction?
Fact? Oh, no!
Sorry, afraid not. Although Mercury's closest to the sun, Venus, that's a bit further away, has got a runaway greenhouse effect and actually gets up to 460 degrees C.
Okay.
Well, you got 0 there, so you did very well.
Well, batting 100.
It's a good question, though. I enjoyed the question. It was really interesting.
Okay, thanks.
Great to have you on the show. Thanks for dropping us a line.
Okay.
Sally, don't forget that we've got our teaser running this week, up for grabs, copy of my book, Naked Science. We want to know how many cigarettes get smoked all around the world every single day. Now, if you are a smoker and you'd like to know how to quit the habit, then perhaps help is at hand, because joining us from Chemistry World is Richard Van Norden. Hi, Richard.
Hi, Chris.
You're going to tell us about these chemical strategies that can help people quit.
Yeah, I mean, in the beginning it all seemed so simple. If nicotine is the demon driving tobacco smoking, then you just give smokers a nicotine fix and that'll keep your hands off the pack. But it's actually 30 years ago since the first nicotine replacement gum was developed in Sweden. And still, according to the US Centers for Disease Control, only 5% of those who try to quit smoking succeed in a year.
With that gum?
With that gum.
Which is not much better off than willpower, is it?
Yeah. But fortunately, chemists have got some new drugs up their sleeves. So number one, marketed in the UK as Champex, and it actually got draft approval on the NHS in March. And I think they're making a final decision in July, so this month. And what it does is it cuts the pleasure of smoking and it reduces the withdrawal symptoms. It's a bit like nicotine. It binds the nicotine receptors in the brain, It does produce dopamine, the pleasure chemical, just like nicotine does, but in a very slow, long-lasting, small sort of seep, whereas nicotine gives you that rush. So you can use it to sort of alleviate your withdrawal systems.
But don't you get hooked on the Champix then?
Well, as far as I'm aware, it's such a small seepage out that it's like nicotine replacement gum, but it's always there. But the clever thing about this is it's a bit like the gum, but if you decide to smoke a cigarette, this drug is already blocking the receptor that nicotine would normally go to. So you smoke a cigarette and you don't get the nicotine rush.
Hasn't it got an interesting history, this drug? Didn't it come from somewhere in Eastern Europe where it was from a tree originally? The idea or the chemical clue that led to it came from a tree in Eastern Europe, I think.
Yeah, the chemical came from the golden rain tree, which is a beautiful name, and that's been used in Eastern Europe since the 1960s by smokers wanting to quit. I mean, the chemists actually changed the structure of the molecule slightly, so it's not the same as the molecule you'll find in the tree, but as with so many chemicals, it
like
came
aspirin.
From a natural product.
Aspirin came from willow trees. Aspirin is totally different, synthetic, but the chemical clue was the willow bark, wasn't it?
Absolutely.
So how does the benefits on Champix compare with, say, Zyban, which made headlines about 10 years ago, 8 years ago, and other things like hypnotism and that kind of stuff?
Well, they're all actually fairly similar. No one has ever managed to breach the ceiling of 30% long-term giving up on smoking. So all of these drugs are, pills that you can take that might help, but we're not very successful so far. One other strategy you could try, which won't be available yet, is actually a smoking vaccine, which I think is incredible.
How does that work?
Well, what you do is you take a molecule that, again, looks a bit like nicotine, and it's a vaccine, so a very small amount, and it stimulates antigens. Antibodies, antigens, do I have the right word? And so when you then smoke and nicotine enters your bloodstream, the nicotine is swallowed up by the antigens in a big complex. Antibodies, I'm so sorry, Chris. And those are, in fact, too big to cross the blood-brain barrier, so the nicotine just doesn't activate the receptors it normally does. Now, this is still in clinical trials, but it's proved promising so far.
There's a similar technique to treat people who are on cocaine. I think they've done the same chemical trick where you take the cocaine and link it to a molecule that makes the immune system react to it, and you make antibodies against cocaine. And I think that the way it works is it sort of blunts the delivery of the drug to the nervous system, so you don't get that big chemical surge of pleasure. And so you forget to associate taking the drug with feeling good, and so it kind of breaks the addictive cycle.
Yeah, I mean, the only problem with vaccination is that the antibody concentrations might not be large enough to counter a serious relapse where you smoke lots of cigarettes. Determined smoker. It may not put them off.
20 cigarettes in the mouth at once.
Well... I mean, another problem is that you may actually not just be addicted to the nicotine. When you smoke a cigarette, you're probably also addicted to the irritating rush of smoke against your throat. So just taking nicotine replacement gum doesn't stop you wanting that rush of smoke. So some scientists told us the best anti-smoking strategy is to smoke a cigarette that doesn't have any nicotine in it, and at the same time take your nicotine replacement gum. And that way you're actually, you're sort of decoupling the two mechanisms. One, the nicotine withdrawal symptoms, that's what the gum is doing. And the other one is that sort of pleasure you associate with the smoke and the sense of a cigarette. And that's what the nicotine-free cigarette is providing.
Well, one problem with smoking is it makes people look a lot older than they really are. And there's a medical phenomenon called smoker's face. And one of the things that doctors look for in a patient when they come to see them is lines around the mouth and the obvious complexion of someone who's smoked for a long time. Now, chemistry has a few things that it can throw at the ageing process now, I understand.
Yeah, I mean, you might remember earlier in May that there were huge queues outside a Boots store when shoppers were keen to get their hands on this anti-wrinkle cream, which Manchester researchers had apparently shown actually worked. In fact, this anti-wrinkle cream contains pro-retinol, an active ingredient. It's not new. It's not exclusive to this product. It's
vitamin A, isn't
it? It's vitamin A. It's a precursor to vitamin A. And vitamin A does, in fact, it has study support that it increases the amount of collagen under your skin, that kind of stringy, fibrous protein that makes your skin supple and elastic. But cosmetics are not drugs. A drug with vitamin A in it, something like a treatment for acne or something like that, you can put in a lot of active ingredient. A tightly regulated cosmetic can only really change the appearance of your wrinkles. There just simply isn't allowed to be enough active ingredient to actually do something to your skin.
But just very briefly, Richard, what sorts of chemicals can you put into your skin to iron out wrinkles in a hurry?
Well, we already mentioned vitamin A. You've also got vitamin C. That's also a cofactor for collagen production. The alpha hydroxy acids that you get from fruit, they're just acidic and they just break down your dead skin cells to leave the new ones underneath. Then there's also your antioxidants that perhaps prevent skin aging by scavenging up the free radicals. And then you've got these peptides, which are copies of the precursors that go towards producing collagen protein. So they're the kind of thing you can put in, and that's all fairly well understood. It's just a case of how much a cosmetic can have in it. Now, what's quite interesting is that a new branch called a cosmeceuticals industry is trying to create much more bioactive products, much more like drugs, much less like cosmetics, and they're trying to inject fillers into your skin which perhaps stimulate your cells to produce more collagen. And whether they're going to succeed in that, which would be a whole billion-dollar industry if it ever succeeded, we'll see.
Thank you very much, Richard. That's Richard Van Noorden from Chemistry World from the Royal Society of Chemistry. You can find out more about what he's been up to on the web at chemistryworld.org.
The Naked Scientist Podcast, brought to you by thenakedscientist.com.
Now, if you want to find out more about science, there's no better way to do it than listening to us here at The Naked Scientist. We would say that. But what can you do between shows? Well, how about seeing some historical medical artefacts and then admiring some classic and contemporary art whilst you're thumbing through the human genome? Well, the Wellcome Trust invited our own Ben Valsler, the kitchen science guy, to the Wellcome Collection down in London to see where science meets art. Hi, Ben.
On the 21st of June, the Wellcome Collection opened to the public. Sited on Euston Road in London, the Wellcome Collection combines 3 contemporary galleries, together with the world-famous Wellcome Library and a new forum for public debate on science. They offer a fantastic lineup of events, including music, storytelling, and even live surgery. I spoke to Dr. Ken Arnold, the head of public programmes for the Wellcome Trust, about what to expect.
The Wellcome Collection has somewhere near 1,500 exhibits, so this is a gallery full of treasures and curiosities. They are arranged in 3 galleries. One of them is called Medicine Man, where we look at the life and work of Henry Wellcome. Alongside that, an exhibition that looks at medicine now, so the human genome, malaria, obesity, and the quest to picture the human body. And then in our temporary exhibition space, we've started with the heart, which looks at both the history of how we've understood the heart, but also not forgetting that the heart is absolutely at the core of our emotional response. So exhibits from around the world that show that sense in which the heart is just as important as a symbol as it is a pump keeping us alive.
Visitors will be entranced by the range of unusual artefacts on display in the Medicine Man Gallery. Consisting of hundreds of examples from Henry Wellcome's personal collection, Medicine Man offers a glimpse of the history of medicine and of attitudes towards the human body.
We came here deliberately because we'd heard good things about the collection, that it was a bit odd, quite eclectic. Maybe Henry Wellcome was a bit of a weird chap, and I think I'm probably beginning to agree with that. There's some very, very weird things here, but it's really interesting.
Certain items in the collection are intrinsically fascinating, as explained by Visitor Services Assistant Brittany Hudak.
I think that so far people have tended to gravitate towards the Peruvian mummy, or even people coming in the door have asked, where's the mummy? Which goes to show that the fascination of the mummified body is apparently still alive and well.
This is a mummified male figure in a sort of fetal position. It's very delicate skin draped over the skeleton. It's between 500 and 700 years old. And one of the things that I'm sure intrigued Wellcome was that actually this is completely naturally preserved. It's simply wrapped in textiles and then dried. So it shows that the people who did this had a strong understanding of how to preserve biological material. And then also, of course, what we're able to do now is apply modern scientific techniques to study objects like this.
I spoke to some of the visitors on the opening day to see what aspects of the collection had caught their eye.
Well, at the moment I'm stood in front of a bunch of nipple shields, which is quite interesting. I certainly haven't seen any of those before.
I think just all the old medical instruments are very interesting and a bit gruesome as well. Dissection models and things like that.
I find it very interesting to see the changes in different cultures and over time that medicine has progressed. So looking at things like the artificial limbs they've had in the past and how much better ours are nowadays is interesting to see.
In contrast to Medicine Man, the Medicine Now gallery focuses on issues in contemporary medicine. In this exhibit, installations of provocative modern art add an extra dimension to an otherwise clinical though fascinating display of the tools of modern medicine. I asked Dr. Arnold to pick a highlight.
This exhibit here is the human genome printed out in all its glory, all 3.4 billion letters of it. So we're standing in front of a bookshelf which is almost 5 meters tall, about 2 meters wide, and it has 120 volumes, all of them about the size of a telephone directory. And to print the human genome in these books, we've had to reduce it to 4.5-point type. So type that's maybe a quarter of the size of an average newspaper type. And you open a volume and you find just millions and millions and millions of C's, of T's, of G's, of A's. And as a source of information, this at once seems like the most extraordinary book of life, both literal and metaphorical, and yet in a curious way it also means nothing to the average person on the street. And there is then this kind of tension here of being the richest source of information that we possibly have, and yet also maybe at the same time the deepest mystery.
In addition to the 2 permanent galleries, the Heart exhibit is the first to fill the temporary gallery, exploring both the anatomical function of the heart and its powerful cultural symbolism. This exhibit includes ancient Egyptian artefacts, Leonardo da Vinci drawings, through to cutting-edge cardiovascular imaging technology. It even detours through the music of Hank Williams.
This is the most recently added exhibit to the Heart Show. It is a human heart. It doesn't look too healthy. It's got lots of yellow tissue on the outside of it. And remarkably enough, this heart was beating inside the chest of Jennifer Sutton just a fortnight ago. So she had a heart transplant operation and was good enough to allow us to put it on display. So we have the remarkable possibility that Jennifer could, when she's feeling a bit better, come in and actually look at her own old heart.
By marrying science with art, historical with contemporary, the Wellcome Collection provides something to engage everybody.
I rather enjoyed today watching people kind of looking at an object and then going and opening one of the cabinets and learning about it and going, oh my gosh, do you know what that is? So I do feel like light bulbs are going off all over. So it really is an individual experience. I think everyone in here could find something different that they would enjoy.
For more information about how to find the Wellcome Collection, its opening hours and details about upcoming events, you can visit the collection's website at www.wellcomecollection.org. And that's it from me. Now back to the Naked Scientist.
Thank you very much. That was our own Ben Valsler, who we sent to the Wellcome Collection down in London. That opened a week ago, just gone, and you can find it. It's actually on the Euston Road, and it's opposite the station, quite conveniently.
OK, a quick update on our teaser now. Remember, the question we've asked you this week is, how many cigarettes are smoked every day worldwide? So a couple of updates here. John in Warrington thinks 40 billion. Tony thinks 2.25 billion. Alan in Lowestoft thinks 15 billion. And 1 billion cigs a day, says Andy in Harwich.
On last week's show, we asked you if you would explode if you fell out of a space rocket without a spacesuit. We had lots of emails about this one, so Sabina's taken a look at it for us this week.
Hey there, welcome to Question of the Week. This week, we're naked in space.
Hi, I'm Sebastian from London. I'd like to know what would happen if I was to fall out of a spacecraft without a spacesuit on. Would I explode as space is a vacuum?
This is a popular question. Milos also posted this on our forum. You can check it out at www.thenakedscientist.com/forum. Lots of science discussions going on there. To answer this week's question, we have a whole constellation of stellar experts. To kick us off, here's Australia's Dr. Karl.
They got it right in Arthur C. Clarke's 2001 A Space Odyssey, the 1968 movie, where David Bowman, the astronaut, is locked out by the crazy HAL 9000, and he bursts into his spaceship by leaping through the vacuum of space from his own space pod and is exposed to that vacuum for about 10 seconds and survives. Now, that's pretty accurate. There was a case back in 1982 where a technician testing a vacuum chamber got exposed to something pretty darn close to vacuum. It was the pressure up at around 22.5 kilometres, about 3-4% of the pressure at sea level, in other words, close to zero. And sure, he was pulled out. He wasn't looking good. Blue in colour, frothing of the lips and bleeding from the lungs, but he had not exploded and also recovered fully. Now, you're thinking, hang on, you've got about 2 square metres of surface area. and your air pressure is 10 tonnes per square metre, so that's 20 tonnes. How does your skin survive? Well, luckily, skin is made of leather, and it doesn't split. You do expand to roughly twice your usual volume, but you do not burst asunder, and providing that you haven't tried to hang on to the air in your lungs and thereby rupturing your delicate feathery lung tissue, just open your mouth and let it all go unconscious. You've got a good chance of surviving, providing the time period is short enough. 10, 15 seconds, you've got a good chance. 2 minutes, not looking good at all.
Professor George Fraser from the University of Leicester has an extra point to add.
It would somewhat depend on whether you got out of the spacecraft on the sunlit or on the dark side. If you got out on the sunlit side without your space helmet on, you get the most tremendous instant dose of sunburn because of the exposure to the ultraviolet light from the sun. And that would do you no good at all. But then, unless you manage to get in again and repressurized, you'd have a very short time to enjoy your suntan.
As always, we're keen to hear your ideas when it comes to solving Question of the Week. Todd is one of our listeners who got in touch. The answer he gave was identical to Dr. Carl's. But being a high-altitude physiologist who trains pilots, Todd was speaking from experience.
Hi, I'm Major Todd Dart with the United States Air Force. I'm an aerospace physiologist with the Air Force Research Laboratory, San Antonio, Texas. I have an answer to the question of the week. Will you explode if you suddenly found yourself outside a spaceship with no spacesuit? Well, the short answer is probably not. Believe it or not, skin is fairly tough, so while you would swell up, your skin would act as its own spacesuit and limit the amount of swelling due to what is called ebulism, or the boiling of body fluids. Fortunately for me, I haven't had any first-hand experience with this. However, there have been a few instances where people have been exposed to near vacuum. For example, in 1960, Air Force Captain Joe Kittinger lost pressure suit in the area that covers his right hand during a balloon ascent to 103,000 feet. While his hand swelled up, it certainly didn't explode, and he was able to successfully complete a record high-altitude parachute jump. Thank you, and have a great day.
OK, Space Cadets, if you ever find yourself naked in space, well, it might happen. Space tourism, the 100-mile high club and all that. Breathe out and get back into the rocket. Quickly, mind, you've got less than a minute. Next week, we'll be staying in space for some sightseeing.
Hi, this is Kevin Kinney in Plainfield, Indiana, and I'd like to know what shape black holes are. They're always depicted as though they're flat. Is that correct? Thank you.
Think you know what shape a black hole is and why? Or perhaps you've got a question of your own. Let me know by emailing questionoftheweek@thenakedscientist.com. But for now, it's back to the studio.
Thank you very much to Sabina. Good to know that you could survive in a vacuum of space, even if it is just for a few seconds. So if you know what shape a black hole is, or if you've got a question you want us to tackle and look into for you, let us know. Email questionoftheweek, that's all one word, @thenakedscientist.com, and we'll have an answer for you next week.
Sorting out the sparks from the quarks. The Naked Scientists.
And this is The Naked Scientists with Dr. Chris and Dr. Phil. It's been our science Q&A show, and right now we'll head back to Ben and Dave and find out what they're doing making a fountain in a cup.
Hello again, welcome back to Kitchen Science. We're still at Parkside Community School. I'm with Dave and Eleanor, and we've got a hard-wearing office-type carpet here. We've got a polystyrene cup full of water, and we're going to make a fountain of it by pushing the cup along the carpet. Is that right, Dave?
That is the plan, yes, Ben.
OK then, Eleanor. Well, if you wouldn't mind pushing our cup along and let us know what you see.
OK. So I'm just going to push it along, my hand's about halfway up to the bottom, and...
Hey! Sorry.
We've just managed to spill water, so again, it's good we brought our own carpet with us. Dave, what went wrong?
I think possibly we're pushing too close to the bottom of the cup. You'll find that the cup tends to vibrate, and you want to just adjust how you're pushing it to try and get the biggest vibrations you can.
Well, we're very sorry if you've got wet carpets at home now, but let's have another go and see if we can make a fountain.
What is another wet carpet?
OK then, Eleanor, one more try.
OK. So I'm just pushing it along, and it's starting to vibrate. Oh, and you can see the water sort of rising up in, like, bumps on the surface.
There were little sort of spits of water jumping out of it, Dave. Is this what you mean by a fountain?
Yeah, maybe it's not 30-foot spout into the air, but you are getting, like, spurts of water out of the thing in a kind of fountain-like manner. And you're getting a really pretty pattern on the surface, which I like, personally.
So why are we getting patterns on a cup full of water?
Well, first thing, as you're pushing it along the carpet, it tends to stick and slip and stick and slip. You may have noticed it vibrating.
Yeah, you can feel it.
So when it vibrates, the water starts to slosh backwards and forwards, and you start getting waves across the surface. And it also tends to change the shape of the cup, so the cup starts to wobble, gets narrower and wider and narrower and wider. So you're getting lots of different sets of waves coming from lots of different directions. And sometimes those all add up. So if 2 waves meet together, they add up and get a bit higher. And if 3 waves meet together, they get up even higher. And if you've got 4 or 5 all coming in a circle, they'll form this kind of spurt upwards. Sometimes a droplet will come off the end of that and fly up into the air out of the cup, making the carpet slightly damp.
So all the waves going in either direction, that's what forms the pattern on the top. And it's only when all of those waves add up together that you get this little spurt of water, the fountain effect.
That's exactly right.
OK, everyone, well, we're terribly sorry if your carpet at home is as wet as our carpet here at Parkside College. But for now, from Kitchen Science, from Dave...
Goodbye.
And from Eleanor...
Bye.
It's goodbye from me.
Thank you very much, Ben. So pushing a cup along a surface like a carpet, it starts vibrating, and this vibration makes waves on the water in the cup, and if enough of those waves meet in the middle, then you get a little squirt of water upwards, a bit like a fountain. And this experiment, along with loads more like that, you can find them on our website, hundreds of them, nakedscientist.com/kitchen science.
And now it's time for the answer to our teaser. That was this week. How many cigarettes are smoked every year worldwide? And Alan's in Lowestoft.
Oh, good evening to you, sir. 15 billion.
15 billion, did you say?
Yes,
so how did you get that number then?
The population of the world is 6 billion and rising.
Indeed it is, yeah. A lot of us.
If you assume, that's an assumption, that 25% of the people smoke.
Yep.
25% of 6 billion. And the average smoker smokes 10 cigarettes a day.
Yep.
You have 6 billion times 2.5, which is 15 billion.
Indeed, you're absolutely correct there. We've got the same answer. 15 billion cigarettes smoked by smokers worldwide.
Well done, Alan. I'll give you a copy of my book and I'll sign it for you. It's Naked Science and it's in the post to you now. Thank you for calling in.
Thank you.
Great to have you on the Naked Scientist.
Bye. Thank you.
And our other quiz winner this week for Fact or Fiction was Kai. He got 1 out of 2 and he came out of the hat. 1 out of 2 on Fact or Fiction. So well done to him. Quick email here from Spar. Don't know how you'd say Spar Rao. He says, Naked Scientist rock, keep it up. I want to join you guys.
Excellent. Thank you very much. We've also got a listener here from Edinburgh. He loves the show. Or fell in love with it in Edinburgh and he's now over in the US. Your podcast is amazing.
This is what we've done to him.
We've sent him away. He loves it that much. And that's, oh, sorry, my apologies. That's from Eleanor in Newport News, USA.
Jason Flakes wants to know from you, Phil, what flames are made of?
Well, actually, flames themselves are just essentially soot particles that are made when the candle or whatever it is burns. And they're lifted upwards by the hot air from the flame, so that rises up, takes these soot particles with them, and because these soot particles are so hot, they're glowing. Just like if you have a poker in a fire, it glows red. Well, the soot particles in the smoke glow yellow colour, and that's how you get the flame.
Ingenious. I've got a question here from Amy. She says, I found 2 leeches in my garden. We don't have a pond for them to live on, and we live on an estate, so what should I do with them? I've got children. I don't really want to put them back. Do you have any suggestions? It's quite intriguing. Because I was actually looking at... this triggered me to go and do a little bit of research on leeches, because I thought leeches had to live in the water, and they don't.
Oh, really?
You can get some leeches that will quite happily crawl out of the water and on the ground surface, as long as they're not going to risk drying out, because they're a member of the worm family.
Oh, right, okay, so maybe a little bit like you get slugs, you just find a damp spot and you can get a slug there even though it doesn't dry out.
Yeah, they're quite happy actually suggesting living outside of water if they have to, so they probably won't harm you. But medically speaking, leeches have been a marvellous thing because, of course, they have this saliva which has got a natural anticoagulant called Hiridin in it, and this stops your blood from clotting, and people are using it as a sort of clot buster. And plastic surgeons love them because when they reattach a severed body part, what you can do is it's very easy to reattach the tiny arteries that bring blood into an organ, but it's much more difficult to find the delicate veins, and so you can end up with a problem where lots of blood goes in and none can get out, and this all clots off and you end up with the piece dying. So
like
if you attach them,
you
attach some leeches, they suck out the venous blood, and the result of that is that lots of blood can flow in, it can get rid of the blood coming back out again, so the tissue doesn't die.
Excellent. I don't like the sound of it myself, though, to be honest.
OK, well, that is it for this week. Thank you very much for listening. Next time, we'll be journeying to the centre of the brain to find out about epilepsy, degenerative diseases, and also out-of-body experiences. So if you've got any questions about any of those things, or if you just want to say hi, please send them to us, chris@nakedscientist.com. We really love hearing from you. Now, a quick favour, nominations have opened for the World Podcast Awards. That's at podcastawards.com, and we really need your support to secure a voting place in the final. So please, if you like The Naked Scientist, consider dropping by podcastawards.com and nominating your favourite science show. Hopefully that's us. Thank you very much to our wonderful production team, Ben and Azzy, Sabina and Dave. Thank you to you for listening, and do drop by nature.com/nature/podcast for some additional science in the meantime. Until next week, have a great week, and goodbye.